In this video, we're going to look at how to find intercepts for linear functions from a graph, table, or equation. Now, what we're going to go over here applies to intercepts for any kind of functions, but we're just going to look at some linear functions specifically. So, in this video, we're going to look at how to find intercepts from a graph, table, or equation. Now we're mostly going to be looking at linear functions, especially with equations, but the rules apply for pretty much any kind of function or graph that we see. So the x-intercept is always going to be on the x-axis, which means it has a y value of 0. The y-intercept then on the other side is always going to be on the y-axis with an x value of 0. So we're going to use this as kind of our guide here through our slide. So again, x-intercept, the y value is always 0, and then that x-intercept is whatever the x value is along our x-axis. Same thing for the y-intercept along our y-axis with an x value of 0. So first, a graph, pretty simple. We just look along our x and y-axis to see where our graph intersects those axes. So this one here, we've got 2 points here where there's an x-axis. So, or excuse me, an x-intercept. So this is at negative 1, 2, 3, and 4, 5. So this would have 2 x-intercepts, one at negative 3, 0, and one at negative 5, 0. Remember, x-intercepts always have a y value of 0. And I'm assuming this is a parabola, so it will have a y-intercept, but it looks like it's going to be a pretty big value, so it's kind of hard to see that from here. This blue line, we see we've got, I should put these points here. So those are the x-intercepts. My blue line, along my x-axis, I've got an x-intercept there. Along my y-axis, I've got a y-intercept right there. So my x-axis, my line intersects at a x value of 3, so 3, 0. Along my y-axis, that's at negative 2, and my x value is 0. This last one here, the orange line, the only intercept I see is this one along our y-axis, and this is a horizontal line. So if it's horizontal, it's parallel to the x-axis. It's never going to cross that x-axis, so we have no x-intercept there. Our y-intercept, we cross our y-axis at negative 5, so we have 0, negative 5 for our y-intercept. Similarly, if this line was vertical, it would be parallel to the y-axis and wouldn't have a y-intercept. From a table, well, we're just looking for 0 for our x or y value. So I see right here, we've got 0, negative 2. That's an x value of 0, which means this is a y-intercept. Here we've got a y value of 0, so this is an x-intercept. So I've got an x-intercept at 6, y-intercept at negative 2. Pretty simple. All right, now for equations. I'm going to go over quite a few equations, so after this first one, it should make sense, but if there are more examples you want to look at, go ahead and continue watching. So again, we want these 0 values for y or x, depending on what we're looking for. So we just substitute 0 in for x and for y. So substituting it in for y to get my x-intercept, we just solve for x then. So we add 2, and then we're going to divide by 3, and we get 2 over 3 for our x value. For our y-intercept, plug in 0 for x. 3 times 0 is 0. And that one's pretty simple. We just end up with negative 2. Okay, so that's all we do for any equation. Just substitute 0 in for x to get the y-intercept, and in for y to get the x-intercept. So here we've got a standard form. If you want to continue looking at these examples, give them a try. So I'm always going to find my x-intercept first, so I substitute 0 in for y. That's nice because it basically just cancels out that term. And now we have 4x equals negative 8. Divide by 4, and I get negative 2. For my y-intercept, 0 in for x, so it cancels out that term. We just get 2y equals negative 8. Divide by 2, we get negative 4. Now your numbers are not going to always be nice integers, but early on that's going to be the case more often than not. So again, substitute to find our x-intercept, substitute 0 in for y. It's going to be 0 minus 2. Now this one I have to get x by itself. I want to get rid of these parentheses, so I have to distribute that 1/5, and 10 divided by 5 is 2. Now I'm going to subtract 2 over, get negative 4, and now to get rid of this 1/5, I multiply by 5 because 1/5 of 5 is 1. So multiply by 5 on both sides, we get negative 20. For my y-intercept, x goes in for 0, so I got to remember my opposite, or my order of operations for simplifying here. And once I simplify all this, then I'm doing opposite order of operations to continue solving. So simplify here by doing parentheses. 0 plus 10 is just 10. And then I'm going to multiply that by 1/5. So we already said 1/5 of 10 is 2. And now we have to add 2 to get y by itself, and we get y equals 4. Okay. Now these next couple examples are a little unique. So we have an x equals negative 12 and y equals 8. So you notice that we don't have x and y in both of our equations. Well, if you remember anything about these types of equations, when there's only an x or only a y and some constant, it's going to be a horizontal or vertical line. So if we think back to the graph, we talked about the horizontal or vertical line is not going to have both intercepts. It's only going to have one or the other. So if we think about this example here, x equals negative 12. That means everywhere on my line, x is negative 12. So then my x-intercept, x is negative 12. But here, my y-intercept says that x equals 0. Well, x can't equal 0 because it's always negative 12. So there is no y-intercept for this example. Similarly here, y has to be 8. Y cannot be 0. So there is no x-intercept. My y-intercept would be at